Okay. Is it the screen is visible?
Yes, sir.
Is the screen?
Oh,
Yes,
sir.
sir.
In the previous lecture, we've seen that what is the irreducible polynomial. Okay. What is the definition of irreducible polynomial? Let f of x belongs to capital R of x and degree of f of x is greater than or equal to 1. That is, f of x is the non-constant polynomial. If f of x is the constant, then degree of f of x is 0. Okay. Then f of x is said to be irreducible. Okay. Irreducible polynomial over R if it cannot be expressed as the product of two polynomials g of x and h of x, which are both are belongs to R of x, such that the degree of g of x and h of x is less than is strictly in between 0 to degree of f of x. Okay, and we saw the some definitions. What are the units? If A belongs to R, it's a unit in R. There exists an element B belongs to R, so that AB is equal to 1. That is, if an element for an element A, if inverse is exist, multiplicative inverse is exist, then that A is called as unit element. Okay, some remarks are there. Look at here. Now, in the f of x, ring of polynomial f of x, f is contained in f of x. So, what are the units in f of x? All the units in f, that is all the constant polynomial in capital F of x are the units in f of x. Okay, we saw some definitions also. Okay, and some remarks. A polynomial which is not irreducible is said to be reducible. Any polynomial of degree 1 over r is irreducible over r. Okay, now some more definitions are there. Look at these some definitions. Okay, let that capital R be a commutative ring with a commutative ring. Okay, and A and B, A comma B belongs to R, and A is not equal to 0. We say that we say A, the element A divides B if there exists C belongs to R such that B is equal to A into C. Okay, so we write this as A divides B. Okay, if A divides B, when we say that if there exists a C belongs to R such that B is equal to A into C. Okay, so this is we can write A is divides B. Okay, so in this case A is called factor of B. Okay, factor of B. Any doubt?
No, sir.
No, sir.
Now, the definition number second. Let capital R be a commutative ring. Commutative ring, and let this A and B belongs to R. Okay, that A and B belongs to R. An element, an element D belongs to R. It's called greatest common divisor of A and B. Okay, A and B. B belongs to R is said to be greatest common divisor of A and B if first condition. Which one first condition? If D divides A and also this D divides B. Okay, and second condition, if there exists C belongs to R such that if that C is divides A and B, then what is the definition of greatest common divisor? That
C
C
less
must
than
be
or equal
divides
to D.
that C must be divides
D.
D.
D, and we denote this D, this D by D is equal to greatest common divisor, that is GCD of E. Okay, any doubt?
No, sir.
हे greatest GCD ची definition आहे नंबर 3 मध्ये पण तुम्ही पाहिला असेल सेम हियर. Okay, now the important remark is there. What is the important remark? First, the GCD, the greatest common divisor of A and B, need not be unique. Not be unique. ओके, एखाद्या दोन एलिमेंटचा जीसीडी हा युनिक नसतो, असायलाच पाहिजे असं नाहीये. नीड नॉट बी युनिक इन दॅट आर कॉम्युटेटिव्ह रिंग. ओके, फॉर एक्झाम्पल, to find the GCD of 6 and 4 in Z, काय ना, ring of integer
2.
2 येणार.
okay, here in Z the GCD of 6 and 4 is 2, but to find the GCD of 6 and 4 in Z, okay, so this is the commutative ring with unity. Okay, now for this GCD of, look at it, 6 and 4. So for this, consider what is the R ring of commutative ring is Z8. Okay, then now look at here. What are the element of Z8?
0 to
0,
7.
1, 2, 3, 4, 5, 6, and 7. These are the element of Z8. Now we can write 6 as a 2 multiplication modulo 8 into रिंग वर दोन ऑपरेशन असतात ना, डॉट आणि मल्टिप्लिकेशन. इथे काय असणार मग? ऍडिशन मॉड्युलो 8 and multiplication modulo 8. Okay, yeah, said it. So 2 into 3 is equal to what? 6, which implies by the divisor, by the definition of divisor, here 2 divides 6. Okay, now again 2 multiplication modulo 8 into 2 is equal to what? 4, which implies 2 must be divides 4. Okay, now look at here. And if suppose C divides 6 and C divides 4, it implies C must be divided 6 minus 4. That is C divides 2. Okay, so thus 2 is equal to GCD of 6 and 4. Okay, take C is equal to 2. 2 divides 6, 2 divides 4. There exists there. That implies 2 divides 6 minus 4. That is 2 divides 2. Thus 2 is the GCD of 6 and 4 by the definition of GCD of AB. Okay. Also, we can write 1 multiplication modulo 8 into 6 is equal to 6, which implies, what it implies? 6 divides 6. Okay, again 6 multiplication modulo 6, which is equal to, what is the answer?
36. 4.
6 is a 36. 36 multiplication modulo 8. 8
4.
4 is a 32. 36 minus 32, 4. Okay, any doubt?
No,
No,
sir.
sir.
Which implies 6 also divides here 4. Okay, now if suppose the C is divides 6 and the C divides 4, we get C must be divide 6. Okay, this one 6, 6. Okay, implies taking the value C is equal to 6. 6 divides 6, 6 divides 4, which implies 6 divides 6 is 6 is equal to GCD of 6 and 4. In what? Z8 ना, हे Z8 मध्ये चालू आहे. Z8 मध्ये येणार नाही आहे असं. Thus 2 and 6 are greatest common divisor in Z8 for the same pair 4 and 6. Hence, GCD in R need not be unique. Okay, any doubt? हे कशामुळे
No,
होतं?
sir.
या आर तुम्ही आर काय काय घेताल त्याच्यावर तुमचा जीसीडी डिपेंड आहे. If suppose if I have taken z is equal r is equal to z, ring of integers, then here the GCD of 6 and 4 must be unique. Okay, 2 येणार तिथे. ओके, हे कशामुळे होते? या मल्टिप्लिकेशन मॉड्यूल ह्याच्यामुळे होते. ओके नाही. So hence in the ring commutative ring R, the GCD of two pairs, two elements 6 and 4 need not be unique. Any doubt?
No, sir.
Now the second remark. Remark number 2. Existence of GCD for any pair A and B in commutative ring R is not compulsory. Existence of the greatest common divisor for any pair in A commutative ring, in a commutative ring R is not compulsory. ओके, एखाद्या दोन एलिमेंटला जीसीडी यायलाच पाहिजे असं गरजेचं नाही. कशामध्ये? इन रिंग आर. ओके, नाउ लुक एट हियर द एक्झाम्पल. कन्सिडर द रिंग आर ऑफ even integers. Okay, R is equal to what? 2z. Is a ring of even integers. Now look at it. 4 and 6 belongs to this R. Now 2 divides 4 in R. 2 does not divide 6 in R. Why? Look at it. Since we can write 2 into 2. The operation काय तुमचा? Multiplication. Simple multiplication is equal to 4, which implies, आणि हा 2 कशामध्ये आहे तुमचा? Belongs to R. It implies 2 divides 4. Now look at here. Since why 2 is not divide 6 in R? Because 2 into 3 is equal to 6. But here this 3 not belongs to R. It implies 2 does not divide 6. Okay? Set of even integer है ना तुमचा रिंग. Hence GCD of 4 and 6 in R is equal to set of even integers. R is equal to set of even integers. Does not exist in R. Okay, any doubt?
No, sir.
काही डाऊट असतील तर विचारू शकता. एनी डाऊट हो की नाही?
No, sir.
बोला ना काहीतरी. समजतंय ना शिकवलेलं काय? कळतंय ना?
हो सर.
कळतंय ना व्यवस्थित?
Yes, sir.
Yes, sir.
Reply द्या कोणीतरी. Now the next definition. What is the associates? Okay, let definition number third na third. Let R be a commutative ring with unity. Okay, and this A comma B belongs to R are called associates. Associates if A is equal to UB, okay, or B is equal to AU. Okay, kahi hai for some unit U belongs to R. If suppose A and B are associates, then there exists an element U such that A is equal to UB, where this U is unit in R. What is the unit? The invertible element in R. Okay? Look at here. What is the meaning of this sentence? That is, U is unit in R. U is unit in R means the multiplicative inverse U inverse, that is U inverse of U exists in R. U is unit in R म्हणजे काय? The multiplicative inverse of U inverse of U, that is U inverse of U in R exists. Okay, for example, look at here. If suppose, for example, R is equal to set of integers. Okay, now take A is equal to 3, that belongs to R, and also B is equal to -3, that belongs to R. Then we have that 3 is equal to -1 into -3, where that -1 which is equal to U must be belongs to R, that is unit in R, which is equal to what? काय तुमचा R तुमचा Z. Okay, -1 का युनिट आहे का Z मध्ये? -1 चा इन्व्हर्स एक्झिस्ट होतो का Z मध्ये?
Yes, sir.
Yes, sir. So here, therefore, 3 and -3 are associate. in R is equal to Z. Similarly, 5 minus 5 into 1 into this minus 5 into here minus 1 into 5. This minus 1 is unit in Z. Hence, minus 5 and 5 are what?
Associates.
Associates. Okay. Now, the next theorem is there. Okay. The next point is look at. Any doubt up to here? Any doubt शायद के इतने?
No, sir.
No,
Okay.
sir.
Okay. Now, the next theorem. Let capital R be an integral domain. Be an integral domain with unity. Okay, integral domain मध्ये unity असतेच, पण काही ऑथर unity असते का नाही हे सांगितलेलं नाही. That's why here taken R be an integral domain with unity. That is commutative ring without zero divisor with unity. Okay. Let R be an integral domain with unity. If the D1, if D1 is equal to greatest common divisor of A and B in R, then G2 is then D2 is equal to GCD of AB in R if and only if D1 and D2 are associates. Okay. As I said, if R is an integral domain with unity, if suppose D1 is the GCD of AB in R, okay, it पण तुम्हाला given दिलेलं आहे. If I take and D2 is the GCD in a GCD of AB in R, if and only if D1 and D2 काय असायला पाहिजे तुमचे associates असायला पाहिजे. Okay. Now look at the proof. Only if part. Let D1 is equal to GCD of AB in R. Okay, what is the only part? I am assuming this D2 is equal to GCD of AB in R, and I have to prove D1 and D2 are associates. Okay. D2 is equal to GCD of AB in R. To prove that D1 and D2 are associates. That is, I have to prove that D1 is equal to D1 is equal to U into D2, or the D2 is equal to U into D1. Okay. By definition of GCD, D1 is the GCD of AB. What it implies? D1 divides A and D1 divides B. Give it equation number 1. Now again, D2 is the GCD of A and B. What it implies? D2 divides A and this D2 divides B. Okay. Now look at here. D1 and D1. This D1 divides A and D1 divides B. Okay. By the definition of GCD, if any element D2 divides A and B, it implies that D1 must be divides D2. Okay. Why? Because D1 is the GCD of A and B. And also, similarly, D2 must be divides D1. Okay. कळतं का हे कसं आलं? GCD ची definition काय आहे? If suppose D1 divides A, D1 divides B, if suppose there exists an element C which divides A and B both, then d1 must be divides c. आता इथे c ची व्हॅल्यू काय घेणार आपण d2 घेणार. So hence by the definition of GCD, d1 must be divides d2. And now for this one, d2 is the GCD of AB. So d2 is it divides a, d2 divides b. But if there exists an element c which divides both a and b, now I am taking c is d1. Hence that d2 must be divides d1. Okay, any doubt?
No, sir.
Definition is काय Addison?
No, sir.
Hmm. GCD definition use केली फक्त. Now we have by the theorem. By the theorem. Which theorem? Let R be an integral domain with unity element. Unity element what? 1. The two non-zero element, A and B belongs to R, are associate. Okay, associates if and only if A divides B and B divides A. Okay. टेक्स्टबुक ए आर वशिष्ठा डायरेक्ट हा थेरम यूज केलाय तुमच्या. Okay, let R be the integral domain with unity element 1. Here R is given that integral domain, and these are D1 and D2 are what? Two non-zero elements. Why? Because they are GCD, greatest common divisor. Means the D1 and D2 must be non-zero. Now here AB belongs to R and R associates. कधी होतील if and only if A divides B and B divides A. Here D1 divides D2 and D2 divides D1. Okay, implies hence D1 and D2 are associate. Okay, now the if part, second part. Let D1 and D2 are associate and also given thing is D1 is equal to GCD of A and B. I have to prove that. To prove that D2 is equal to GCD of A and B. Okay. Now look at it. Wait a minute. Okay. I have to prove that G2 is the GCD of AB. Na? G1 divides. Now look at here. Hence, here we taken D1 and D2 are associate. What implies D1 is equal to U into D2, where U is unit. Hence, D2 must be divides D1. Okay? D2 must be divides D1. Now, D1 is what? GCD of AB. If D1 is equal to GCD of AB, D1 and D2 associated. याचा अर्थ काय? D1 is equal to U into D2. Okay. Hence, D1 must be divides D1 by the definition of divisors. Okay. If D1 is the GCD of AB, implies D1 divides A and D1 divides B, and also if D2 divides D1, hence D2 कोणाला डिवाइड करतोय D1 ला, पण डिवाइड कोणाला करतोय A ला, hence this D2 must divides A and this D2 must divides B. Okay, why? Since D2 divides D1 and D1 divides A implies D2 divides A. Now here D2 divides D1 and this D1 divides B, which implies this D2 divides B. Okay, this is the reason. Okay, look at here. Now D2 divides A, D2 divides B. Let now X belongs to R such that X divides A and X divides B. Okay, that X belongs to R such that X divides A and X divides B. Look at it. Wait a minute. Then D1 is equal to X divides. Wait a minute. Okay. Now, let X belongs to R such that X divides A and X divides B. But we have D1 is the what? GCD of AB. Why? Given to us. D1 is the GCD of AB. By the definition of GCD of AB, that X must be divides D1. Okay, that is X divides D1. Okay, which implies, what is the meaning of this sentence? D1 is equal to X into T for some T belongs to R. Okay, but what is the value of D1? U into D2. Why? Because D1 and D2 are associates. So here we write the value of D1 is U into D2, which is equal to X into T. But what is the U? Is unit element. Unit element means what? There exists an inverse of this element, which implies D2 is equal to U inverse into, now R is the what? Commutative ring. So here we can write instead of xt, Tx into X, since U is unit in R. Okay, that implies X. What is the meaning of this? X must be divides T2. Now look at here. D2 divides A, D2 divides B, and there exists an element X belongs to R such that X divides A and X divides B implies X divides D2. That means the definition of GCD here satisfied, which implies D2 is equal to greatest common divisor of A and B. Okay, hence the proof. Any doubt?
No, sir.
Okay, नीट लक्ष दे. Only part. D1 and D2 are the associate given to us, and D1 is the GCD of AB. Also, this is given to us. Now I have to prove that D2 is the GCD of AB. What is the meaning of associate? D1 is equal to U D2. Okay. Now here, look at here. D1 divides A. D1 divides B. Hence, this D2 must be divides D1. Why? From this definition. D2 must divides D1. Okay. Now, what is the D1? GCD of A and B. That is D1 divides A, D1 divides B. Hence, D2 divides D1 D1 divides A, that means हा A कोणाला डिवाइड करणार तुमच्या A ला डिवाइड करणार, हा D2 कोणाला डिवाइड करणार B ला डिवाइड करणार, तेच दिलेलं आहे. ओके, नाव implies that is D2 divides A and D2 divides B. Now let take any x element belongs to us so that x divides A and x divides B. आपल्याला काय प्रूव्ह करायचं आहे, हा तुमचा D2 जीसीडी आहे कोणाचा A आणि B चा, म्हणजे तो A जीसीडी ची डेफिनेशन सॅटिस्फाय करायला पाहिजे. ओके, for this one I taken x belongs to R so that x divides A and x divides B. Now what is D1? D1 is the GCD of AB, that is x must be divides this D1. Okay, so x divides D1. What is the meaning of x divides D1? D1 is equal to x into t for some t belongs to R. But what is the value of D1? U into D2. Okay, why? Because they are associates. So this is associates, definition of associates. But U is the what? Unit element. That means inverse exists. So D2 is equal to inverse into T into X. Why we write like this? Xt is equal to Tx because R, this is the element of R. This is the element of R, but R is commutative. Hence, Xt is equal to Tx. Okay, that's why. What is the meaning of this one? This one is X must be divided D2. Now, hence, the GCD, the definition of GCD is satisfied. Hence, D2 is the GCD of AB. Okay, any doubt?
No, sir.
No, sir.
काही डाऊट असतील तर विचारू शकता बरं का. पहा बघून घ्या. Okay, now the next definition is improper devices. जायचं पुढे. Definition of improper devices. Okay, look at here. Let D, capital D, okay, capital D be an integral domain with unity element 1. Unity element 1. Okay, if P belongs to capital D and P is equal to x into y. Okay, P is equal to x into y, where this x and y both are the element of D. Okay, wait a minute. P is equal to x into y, and these both are the element of D. X and y belongs to D. Then one of x or y must be unit in D. Then x and y are improper or trivial divisors of P. Okay, one of them is what? Improper divisors or trivial divisors of P. Okay, let D be an integral domain with unity, an element of unity element 1 if P belongs to D and P is equal to x into y, where this x and y belongs to D then one of the x and y must be unit in D. Then that x and y are called improper or trivial divisors of P. Okay. For example, theoretical domain. R, suppose I taken D is equal to Z, which is integral domain. Okay. Now, if I am taken 3 belongs to D. Okay. So I can write 3 is equal to minus 3 into minus 1. This is x, this is y, this is our P. So where x and y belongs to D, I have yes, minus 3 and minus 1 belongs to Z. Then one of the x or y must be unit in D. तुमचा minus 1 काय y belongs to D. That is minus 1 belongs to D is unit. आहे का unit? Invertible element आहे का? Yes.
Yes, sir.
Inverse of minus 1? Minus 1 in Z. Okay, so here the minus 3 and minus 1 are improper divisors of 3. Okay, okay. Now, for example, Z5. Today, proper divisors. Okay, this is the examples of improper divisors. Now, the definition of proper divisors. Now, 0 not equal to B belongs to wait a minute. 0 not equal to B belongs to the element 0 not equal to B belongs to that D. What is the meaning of this? Non-zero element B belongs to D. Okay. Then we can find x comma y belongs to D such that P is equal to x into y and none of x comma y belongs to D are unit in D. Then x and y are proper divisors of B. Okay, take this one. For R is equal to set of integers. Suppose P is equal to or B is equal to. B is equal to 6. Okay, Z is integral domain without zero divisor. Now we can write this 6 is equal to 2 into 3, which is into x into y. Okay, now x and y are what? None of x or y is unit in D. So here 2 and 3 are the proper divisors of 6. Okay, so this is the definition of proper divisor. Any doubt?
No, sir.
Now the next definition is prime element. Or the prime element is also called as irreducible element. Irreducible element. हे सगळे डेफिनेशन व्यवस्थित लक्षात ठेवा बरं का. आहे तसेच तुम्हाला एमसीक्यू ला विचारू शकतात. प्राइम एलिमेंट्स और irreducible element. Let let D be an integral domain. Let D be an integral domain with unity. Okay, unity element. What is the unity element? 1. A non-zero non-unit. तो एलिमेंट कसा पाहिजे? नॉन झिरो हवा आणि नॉन युनिट एलिमेंट. A belongs to D having only trivial, that is improper divisors. ट्रिवियल चा अर्थ काय? improper divisors. Okay, it's called a prime element. Prime element or irreducible element of capital D. Okay, that is, what is the meaning of this sentence? That is, if the P is prime element of D, okay, and I have P is equal to X into Y, where X and Y, that both of the elements belongs to D, okay, then one of X comma Y, okay, one of X or Y must be unit in D. Okay, याचा अर्थ काय? ट्रिवियल डिव्हायसेसचा अर्थ काय? या दोघांपैकी एक तरी काय हवा आपल्याला? युनिट इन डी, जे इथं पाहिलं. ओके, वन ऑफ एक्स और वाय मस्ट बी unit in D. Hence we called X and Y are improper or trivial divisors. For example, again, if D is equal to Z, what is the prime element of Z's? Take any prime number. P is equal to 5. How can I write? I can write 5 into 1. Okay. Now 5 into 1. One of them. This is X. This is Y. This Y belongs to D is unit in Z. Okay, and also I can write this 5 is minus 5 into minus 1. Okay, or this is X, this is Y. Here Y belongs to D is unit in Z. Okay, हे का सांगतो नीट लक्षात द्या. 5 is equal to 5 into 1 असं लिहू शकतो किंवा 5 is equal to minus 5 into minus 1 असं लिहू शकतो. ओके, पुढे जाऊन तुम्हाला युनिक फॅक्टरायझेशन डोमेन बघायचं, त्याच्यामध्ये हे डेफिनेशन लागतं आहे तुम्हाला. ओके, सो दिस इज द डेफिनेशन ऑफ प्राइम एलिमेंट और इररिड्यूसिबल एलिमेंट. ओके ओके, आर ऑफ एक्स मध्ये प्राइम एलिमेंट काय येतील? समजा रिंग ऑफ पॉलिनॉमियल, त्याच्यात जे कोणी इररिड्यूसिबल पॉलिनॉमियल असतील ते सगळे कसे असतील? प्राइम एलिमेंट असतील. ओके, फॉर एक्झाम्पल हे घेऊन आर ऑफ एक्स, let's suppose you have q of x. Okay, now f of x घेतलं त्याची मगाशी x square plus x square minus 2, x square minus 2, which is belongs to this q of x. Now this x square minus 2, which is equal to x minus root 2 x plus root 2. Okay, belongs to q of x. आहे का? No, that's why this x square minus 2 is irreducible. Okay, irreducible in Q of x. लिमिट आहे का काउंट करून नाही ह्याचा ह्याचा उपयोग irreducible एलिमेंट आणि प्राइम एलिमेंट नाही हे नाही म्हणावं लागणार. ओके, irreducible एलिमेंट म्हणजे irreducible पॉलिनॉमियल असतो का नाही. ओके, याचे एक्झाम्पल अजून नंतर सांगू, तेवढेच लक्षात ठेवा. ओके, दिस इज द डेफिनेशन ऑफ प्राइम एलिमेंट अँड irreducible एलिमेंट. Okay, now the next definition is reducible. Reducible or composite element. Okay, what is the definition of reducible element? An element non-zero B belongs to D, having proper divisors. It's called reducible or composite element in integral domain D. Okay, of D. Okay, composite element of D. That is, what is the meaning of this sentence? If 0 is not equal to B, that is non-zero B belongs to D, is reducible. Is reducible element of this capital D. If and only if we can find two elements x comma y belongs to this capital D such that B is equal to x comma x into y and none of x and y is unit in D. Okay, for example, again D is equal to z, take B is equal to 6, which is equal to 2 into 3. So this is the composite element or reducible element. None of 2 and 3 are unit in D. Okay, any doubt in this definition?
No, sir.
Okay, the last definition is there. Relatively prime elements. Relatively prime elements. Okay, look at here. Let capital D be an again integral domain with unity element 1. Unit element 1. The two elements A and B belongs to that capital D are said to be relatively prime if their greatest common divisor. What is greatest common divisor is?
1.
Unit of D. Okay, तुम्ही प्रॉपर D is equal to Z साठी 1 म्हणताय. आपण सगळे आतापर्यंत ग्रेटेस्ट कॉमन डिवायझर कुठले बघितले? नंबर थेरी मध्ये काय होतं ते नंबर सगळे कुठले फंक्शन आहेत त्याच्यामध्ये इंटिजर्स असतात सगळे. ओके, नंबर थेरी मध्ये कुठेही 1/2 1/3 मायनस असे येत नाही, सगळे ते इंटिजर फंक्शन असतात. ओके, युलर्स फाय फंक्शन आपण एका एक्झाम्पल साठी सांगतो. डी इज इक्वल टू झेड असेल तर काय असतं तिकडे ग्रेटेस्ट कॉमन डिवायझर तिथे 1 असेल. बट हियर इन आर और इन डी be an integral domain with unity element 1. A and B are said to be relatively prime if the greatest common divisor is unit in D. Okay, unit of D. So this is the definition of relatively prime number. If suppose D is equal to Z, then greatest common divisor is 1. If A and B are relatively prime. Okay, up to here. Any doubt?
No,
No,
sir.
sir.
ओके, सोप्या सोप्या डेफिनेशन आहेत. फक्त तुम्हाला एक्झाम्पल थोडे व्यवस्थित घेतले की मग ते होऊन जाईल, कळून जाईल. ओके, आपल्याला एक्झाम्पल शक्यतो कमी आहे. ओके, वेट अ मिनिट.